All right, let's take a look at this thing. And this thing is going to be kind of a nightmare, but let me kind of explain this to you, okay? Let's take a look at this thing and kind of approach it each piece by piece. I know that the vertical asymptotes is going to be over at x equals 1. So I'm going to do a little red line. Do I got a red line going on? Yeah, I'm going to do a little red line at -1. Oops, that is horrible. And +1. So I know that's going to be where my vertical asymptotes are. Okay. Now I'm also, because I looked at the denominator and that's kind of what it says. Now here's the hard part, is when I was able to, what I did was, one of the first problems I did for you is I FOILed out the bottom. Okay, fine, I can FOIL out the bottom, and that's pretty straightforward. I know that first, outer, inner, last is going to be, first is going to be 1, and then I've got plus x, and I've got negative x, and I've got negative x squared. This cancels out, and so basically I have negative x squared plus 1. That's what my denominator is going to be. Alright? But here's the thing, folks, is this numerator is going to be a nightmare to try to expand, because this thing is going to be, alright, this first thing alone is going to be x squared minus 4x plus 4. And then I'm going to have to multiply that by this thing alone, and that's going to be x cubed plus something plus something plus something plus something. All right? And then I have to multiply out those two things together, and it's going to be horrible. But one of the things I do know is this. I know that if I multiply this thing by this thing, the biggest number, or the biggest term that I'll get, is x to the 5th power. I even know what the number in front of it's going to be. It's going to be x to the 5th power with no numbers next to it. It's just going to be that. Let me zoom out just a little bit. Alright. So, on top I have x to the 5th power. On the denominator I have negative x squared, because this thing is going to have plus some number times x to the 4th power plus some number times x to the 3rd power, and so on and so forth. But remember, when I'm looking at only the end behavior of this, I'm only caring about the leading term. So all of these terms are going to crash and burn. So I don't even care about that. Essentially, I think that this thing is going to look like x to the 5th power divided by negative x squared. Well, that's just straight up, if I were to simplify that, that's negative x cubed. Okay? Well, x cubed, the graph of that looks like this. So the negative version of that would look like this. I claim that the graph is going to probably go up like this and down like that in the end. In the end behavior. And if we were to graph this, and I know it's kind of a, I mean, this is why we use the graphing calculator, because I mean, I wouldn't want to have to graph this by hand. Actually, I wouldn't mind. It's not that bad, but let's try this. It's x minus 2 squared, x plus 3 cubed divided by x minus, or sorry, 1 minus x and 1 plus x. Now, if we look at this thing over here, yeah, it's going to have some funky stuff going on over there. It's going to do some weird stuff in the middle, but I don't care what that weird stuff it does in the middle. What I'm really most concerned with, or like interested in, is the end behavior. And like I said, it goes up to infinity on this side and down to negative infinity on that side. That's what I said it would happen. That's what ended up happening. So that's pretty cool. Alright, let's try this one. Example number 2. Alright, well, actually, you know, I got a call coming in, so I'll talk to you guys later.